Alright, 6.4, they talk about present value of an annuity or an annuity due. The best way to explain this is if somebody wins a mega lottery, like they win $100 million, they have two choices. They can take a regular payment every month, monthly for like 20 years, and it ends up giving them a total of $100 million at the end of the 20 years. Or they can take a cash amount, which is what they call it, which is in these words is present value, meaning a certain amount of money right now. And it's usually about a third of what they really earned. If they got a $100 million lottery ticket, they usually get about 35 million instead of the 100 million payout. But if they were to stick with their regular payments every month for 20 years, they would get equal payments adding up to a total of $100 million. But a lot of people don't want to wait, and they decide to take all their cash right now. So the cash out value is your present value of an annuity that you know would go out for so many years. Alright, so 6.4, number 1. Okay, they give you everything here, and they ask you what's the A sub n, which is your, they call it the requested value, A sub n. So you plug in all the things that you know, and here you got to be careful because you've got a negative exponent in the top, and then you got to do 1 minus that, so be very careful. This is 1.04 raised to the negative 30. You figure out what that is, and then you take 1 subtract this. It's very easy to do the exact opposite of this, subtract 1. Don't do that. So 1 subtract what you just figured out. And the way you can do that is you plug in 1.04 hat negative 30, hit enter, okay, and then do 1 subtract, and then when you want to pull up the number you just found, hit second enter, and it should say 1 subtract ANS, and ANS was the previous number that you just calculated. And when you hit enter, it tells you what the top is, divide by 0.04, tells you what that is, times 1300 tells you what that is. Okay, now here they want you to figure out what R is. So again, you can actually figure out what all this is in the top all in one shot. You can say 1 subtract parentheses 1 plus 0.005 parentheses hat negative 360 and hit enter. Divide 0.005 and you get this. Divide by 166.79 something and you get 809.39. Number 4, they say find the present value of the annuity that pays $3,000 at the end of each 6 months. So it's compounded semi-annually, 6% for 6 years. So semi-annually is 2 times t is 6 is 12. 6% over compounded semi-annually is 2, so it's 0.03. So you plug in everything you know, and again you got to be careful here. 1 minus 1.03 to the negative 12. Enter. Divide by 0.03. Enter times 3,000, enter. 5 is the same way. Again, you plug in everything that you know, and they're asking you to find the present value. This is actually a lottery. A lottery ticket that's worth $250,000 is worth how much present value. And so you plug in all the things that you know, and you plug them in here, and you carefully calculate, and you get $212,000. Instead of $250,000. Number 6, how much is needed in an account that earns 8.4% compounded monthly to withdraw $1,000 at the end of each month for 20 years. So T is 20, compounded monthly is 12, so it's 240. R is 8.4 divided by 12 is 0.007. R is 1,000. So you get all this, crunch it down, and you get $116,076. So number 7, present value is $135,000. What's the size of the withdrawals are? It can be made at the end of each quarter for the next 10 years. So 4 times 10 at 6.4% divided by 4 gives you that. Okay, so you plug in everything that you know. I is 0.016, N is 40, I is 0.016. Crunch all that down, you get 29.3 something. divide both sides by 29.3 something. And there you get 4595.46. Okay, number 9. Number 9 says a personal account earmarked as a retirement supplement contains $242,400. Suppose $200,000 is used to establish an annuity that earns 6% quarterly and pays $454,500 at the end of each quarter. How long will it be until the balance is zero? Okay, so you've got 200,000 is the ending amount. You got your regular payment of 4,500, and you get your R, I, and your N. You crunch this whole thing down. You don't know what T is, so you got to divide by 4,500. Then you multiply by 0.015. Then you subtract 1. Divide by -1. And now you can write this with a log. Log base this of 1/3 equals -4t. You figure out what that is. Divide by -4, and now you've got t is 18.44, or 73.78 quarters when you multiply it by 4, which is roughly 74 quarters. All right, number 15. Number 15, they ask you what's the difference between an ordinary annuity and an annuity due. Ordinary annuity withdraws the money at the end of each period, and an annuity due withdraws at the beginning of each period. Okay? So notice that the present value problems, you're getting money out of these accounts. This is money that you're paid every month or every quarter or every year. This is money that you're paying into an account every quarter, every month, or every year. All right, so 17, find the present value, A. If it pays 3,000 at the beginning of each quarter, so you know it's due. 5.8% quarterly, so 0.058 over 4. Quarterly is 4, T is 7, so you get 28 there. Plug in everything that you know, crunch it down very carefully, and you get 69,632.02. 19 is the same idea, just different numbers. Slightly higher interest rate, compounded annually, not quarterly. 12 years instead of 7. You crunch everything down, and you get 445,962.23. 20, this is an annuity due. All right, so it pays 15,000, so that's your R. T is 7. Interest rate is 0.073. Annually is your M, and so you get 0.073 is I. N is 7. Plug everything in. Again, you crunch it down carefully, and you get 85,840.70. 21. 21 says a year-end bonus of 25,000 will generate how much money at the beginning of each month for the next year? Alright, so on 21 we have end of year bonus of 25,000 will generate how much money at the beginning of each month, so that's your payout of R. Interest rate is 0.0648, compounded monthly, so N is 12. M is 12, T is 1. And so you're looking for R. So you plug in everything you know, crunch everything down carefully, multiply it by 1.0054 in this case. You get this, divide both sides by that, and you get 2145.59. 25. 25 says the company wants to have $40,000 at the beginning of each 6-month period, so it's going to pay out $40,000 twice a year for 4.5 years. So 4.5 is your T. 6.68 compounded semi-annually. 6.68 over 2. M is 2. So N is 9. I is 0.034334. So you plug in all the things that you know here. Be very careful crunching this down, and you get 316,803.61. 28. As a result of a court settlement, an accident victim is awarded $1.2 million. The attorney takes 1/3. Alright. Another third is used for immediate expenses, and the remaining third is used to set up an annuity. So 1/3 of 1.2 million is 0.4 million, or 400,000. Okay. And they want to know how much this thing will pay off every quarter. It's compounded quarterly for 5 years at 7.6%, so 0.076 over 4. Quarterly times 4 times 5 years is 20, and so you plug in everything you know, and you simplify this down to 16.8 something and divide by 16.8, and you get a payout every 3 months of $23,775.52. Number 30. A $2.4 million state lottery paid $10,000 at the beginning of each month for 20 years. It's compounded quarterly at 6.3%. How much money must the state actually have on hand to set up payments for this prize? So they got to know how much they're going to have at the end of this annuity. Okay, so R is 10,000. R is 0.063 over 12. Gives you this guy. N is M times T, or 12 times 20, or 240. So you plug in everything you know, crunch everything down very, very carefully, and you get roughly 1.36 million. Okay, and 37. 37 says, Juanita's parents want to establish a college trust fund for her. They want to make 16 quarterly withdrawals for $2,000 with the first withdrawal 3 months from now. Okay. If money is worth 7.2 quarterly, how much must be deposited now to provide for this trust? So they want to know how much you have to start out with so you can take out $2,000 as you go along. So I is R over M, N is M times T, so you get 0.018 and 16. Plug everything in, and you get 27,590.62.